Hello viewers, welcome to Physics with Sanmitra. I am Sanmitra Bhomik, and today in this video we are going to provide solution of Newton's laws of motion level 1 problem sheet solutions. We have already given the solution of problem 1 to 4 in the previous video, and let's start from problem 5. A bullet is fired from a gun. The force on the bullet is given by Ft is equal to 600 minus 2 into 10 to the power 5t, where F is in Newton and T is in seconds. Now, force on the bullet becomes 0 as soon as it leaves the barrel. Find the average impulse imparted to the bullet. Okay, let's see what the question actually means. See, there is a force. And it says it's an impulse. This is T. Let us draw the plot. At T is equal to 0, force is 600 Newton. And remember, 600 Newton is very high. 600 Newton is very high. Let me draw it here. F is equal to 600 minus 2 into 10 to the power 5 T Newton. But T is in seconds. Now let me plot the graph. This is F, this is T. This is 600 Newton. Now let me find at which time it will be 0. So F will be equal to 0 at T is equal to T naught, let me say. At T naught is equal to 600 by 2 into 10 to the power 5. That will be 3 into 10 to the power minus 3. 3 into 10 to the power minus 3 seconds. That is very less. 3 into 10 to the power minus 3 seconds. That is almost equal to 0, I can say. It falls back like this. I am just showing 3 into 10 to the power minus 3 in such a time. But actually in the actual graph, it will be something like this. It will be something like this. This is the impulse. Impulse is something like a spike. Impulse is something like a spike. Now, the average impulse we have to find, this force into time. So we'll integrate it. Now, can you see one thing here? If I integrate this curve, what will I get? For that, I can integrate it. That will give me the area of this curve. So what is the area of this curve? If I have to integrate integration of f dot dt, f into dt, that is 0 to say t naught, because after that this value becomes 0. So I can find half into here, that is 600 into 3 into 10 to the power minus 3. So 3 3s are 9 and 10 to the power minus 3, I will get 0.9 Newton second. So this is my answer. My correct answer is option D. So I hope I can tell you what is the average impulse. Now the next question. Upper half of an inclined plane of inclination theta is completely smooth while the lower half is rough. A block starting from rest at the top of the plane will again come to rest at the bottom if the coefficient of friction between the block and the lower half of the plane is mu is 2 tan theta, mu is tan theta, mu is 1 by tan theta, and mu is 2 by tan theta. Let's understand what the question is telling. Yeah, you can pause and read it once again. It's a big question. See, and we will solve it in a very unique manner. Maybe the concept you will learn in the next chapter, but still, this is theta. The first half is smooth and the last half, second half, is rough. Okay. Now I am keeping a block here, block of mass m. This block of mass m, at first it will start falling in this. So when it will be at the juncture of the smooth and the rough surface, that time it will already gain some velocity v. Had it been totally smooth, then it would have continued to increase its velocity by an acceleration, that is g sine theta. But since the surface is rough, after entering the rough surface, there will be some friction that will be acting in the opposite direction to the motion, to the relative motion between the block and the wedge. That time after reaching the ground, it will become 0. It will become V is equal to 0. Now, what I can do here is that, let me draw it again. So, now understand this question very carefully. I am releasing it from the top, and at the end it is becoming 0. It was 0 in the beginning. At the juncture it gained some velocity, that is some v. Then after that again it becomes 0. It slowed down and becomes 0, and here it is theta. Now let's see, it is telling the half of the inclined plane. So definitely this height will be h by 2, this corresponding height. If I draw a perpendicular here, this is also h by 2. Just understand this very carefully. Many of you have done the problem correctly. At first you calculated this. At first what you did, you calculated this v. Then what you did, then you calculated the acceleration here, that is this friction force, the mg sin theta minus f, that you have calculated f minus mg sin theta, because f minus mg sin theta you have calculated. That is ma. That is all correct. Then you have equated this one to 0. That is all correct. But I will tell you one single formula by that you can solve it in a single line. This is not shortcut, but this is application of concept. And this concept is linked to the next chapter, which I will teach you in a short period of time. Soon I will be starting work per energy, and this is linked with work per energy. Let me show you. The work, this velocity that it is gaining here, or I can tell you, the net change in energy, see the net change in potential energy from, the change in potential energy from, say, or let me use the work energy theorem. That is, the change in kinetic energy is work done. What is the change in kinetic energy? Initially kinetic energy was 0. Finally also the kinetic energy is 0. So there is no change in kinetic energy. Change in kinetic energy is 0. Now work done by gravitational force, what is that? Work done by gravitational force, see, gravity is acting in the downward direction, mg, and it is making a displacement h. So I can write plus mgh, plus mgh. Now due to normal reaction, another force is acting here, there is normal reaction. Due to normal reaction, work done is 0 because the body is displaced in 90 degree with the normal direction. Now this is mgh, and just see work done by the friction. Friction is acting only after this point. So what I can show here is that, what is the value of friction? Friction is mu mg cos theta. Friction is, I can write here, mu n. That is, n is mg cos theta. In case of inclined plane, I have already shown you earlier. Friction is mu mg cos theta. So I can write mu mg cos theta into this distance. What is this distance? This will be, I can write here directly, h by 2 into 1 by sin theta. That is h by 2 into sin theta. This is h by 2, this is h by 2 sin theta. So if I can write it now properly, mgh minus mu mg cos theta by 2 sin theta. So that my mu will come out to be, 2 tan theta. So that's it. So in only one line we can solve this question. Now the next question I have, sand is being dropped on a conveyor belt at a rate of lambda kg per second. Force necessary to keep the belt moving with constant velocity of v meter per second will be lambda v by 2 Newton, 0 lambda v Newton, and 2 lambda v Newton. Let's understand the situation at first. I have a conveyor belt. This conveyor belt is being moved. Say there are 2 rollers and they are applying the force here. They are applying some force here, and here is some force, rather torque, and they are applying some force. This is moving with a constant velocity, say V. There are some mass which is present on the conveyor belt, mass M, say, at present. Now it is moving, so now momentum is linear momentum at the present of the mass present, that is mv. Now what will happen if I suppose what will happen if I put an additional mass of, say, del m, and this force is 0, there is no force. What will happen if I put an additional mass del m? Then due to the absence of an external force, linear momentum will be conserved. Linear momentum will be conserved. So I can write, if m is increasing, then definitely v will decrease to keep p constant. But we are actually keeping the v constant, so we have to provide some force. So this will not be equal to 0. There will be some force. Okay. So what I can write here? I can write here P is equal to m into v. Force is equal to dp by dt. That is dm by dt into v plus m into dv by dt. But they have told us that we are using constant velocity, so this I will be making it 0. So F will be dm by dt into v. What is dm by dt? Lambda. Lambda into v, Newton. I can write this is lambda into v. So my correct option is option C. And the last question for today, that is, a heavy uniform chain hanging from a rough table, mu is equal to 0.25. Maximum fraction of length of the chain that can hang over the edge of the table. Maximum fraction of the length of chain that can hang over the edge of the table. Okay, let me assume that this is a question of equilibrium, and let me assume that the fraction of the length of the chain is L, total length is L, and this is the fraction hanging is X, and the fraction lying on the table is L minus X. What is the mass, the total mass? Let it be M. Now what I can say, the mass of the hanging portion is M into X by L, and let's see now, let's draw the free body diagram of the chain. See, this is the mass of the chain that is on the table, and this is the chain that is hanging. I have separated them mentally. Now here m into X by L into G, that will be acting downwards, and a tension will act upwards. This tension will act like this here, and friction force will prevent it from slipping. And what is friction force? See, this is the mass of the remaining part of the table, that is m minus mx by L whole into G. This is the weight, and this is the normal reaction. And I know what is friction. Friction will be mu into n, and n will be this weight in m of 1 minus x by L into G. M of 1 minus x by L into G, this is my normal reaction, and into mu, that is my friction. That friction will be equal to T. That T is equal to F, and also T is equal to mx by L into G. Mx by L into G. Now what I can write then F is equal to mx by L into G. So if I erase this part, so I can write here m x by L into G is equal to mu m G 1 minus x by L. This is L. Now I can cancel out mg and mg. I will get x by L is equal to mu into 1 minus x by L. So after solving, I will get here x by L is equal to mu into 1 minus x by L. So x by L minus plus mu into x by L is equal to mu. So I will take x by L common. I will get 1 plus mu is equal to mu. Now I can get x is equal to mu L divided by 1 plus mu. Mu L by 1 plus mu. Now let me see here what is the value of mu. Mu is 0.25. So mu by 1 plus mu, what is that? That will be 0.25 by 1 plus 0.25 into L. So L by 5 it will be L by 5, because 0.25 by 1.25, that is into 100, that is 0.20% of L. So option A is correct. So that's all for this video, and if you like our content, then please share this video and subscribe to our channel. Thank you.